In this figure, A, B, and C are points on the circumference of a circle center O. Line PQ is a tangent at A, angle ABC is 52 degrees, and angle BCO is 20 degrees. Find the value of angle X, Y, and Z. Let's go ahead and solve. Here, X is the angle between the chord and the tangent. Let's recall the circle theorem of the angle between the chord and the tangent. It states that the angle between a tangent to a circle and a chord through the point of contact is equal to the angle in the alternate segment. From this figure, A, which is the angle between the tangent and the chord, is equal to B, which is the angle in the alternate segment. That is, angle A is equal to angle B. Hence, X equals 52 degrees. Next, let's find angle AOC. Doing so will enable us to find angle Y. Angle AOC is the angle at the center of the circle. From the circle theorem of angle at the center, it states that the angle at the center is twice the angle at the circumference. From this figure, the angle at the center is 2x, since the angle at the circumference is x. Hence, angle AOC is 2 times 52 degrees, which is equal to 104 degrees. Now, to find the angle Y, Y is in a straight line with 104 degrees. So, Y plus 104 degrees is equal to 180 degrees. Reason. The sum of angles in a straight line is 180 degrees. Now, we can go further to solve for angle Y. Y is equal to 180 degrees minus 104 degrees, which is 76 degrees. Before we proceed, if you're new to my channel, hit the subscribe button so you make sure to never miss my videos. Next, let's consider triangle AOC. In triangle AOC, line OA is equal to line OC. Reason. Both are radii of the circle. Since both sides are equal, it follows that triangle AOC is isosceles. So, angle OAC is equal to angle OCA. Reason. Base angles of an isosceles triangle are equal. Going further, let's find angle OCA. This will enable us to find angle Z easily. Since angle OCA is a base angle of an isosceles triangle, it follows that angle OCA is equal to 180 degrees minus 104 degrees, divided by 2, which is 38 degrees. Now we have known angle OCA. Let's go ahead and find angle Z. Notice, also that angle Z is an angle between chord and tangent. Let's recall the circle theorem of the angle between the chord and the tangent once again. It states that the angle between a tangent to a circle and a chord through the point of contact is equal to the angle in the alternate segment. Since A, which is the angle between the tangent and the chord, is equal to B, which is the angle in the alternate segment, it follows that angle Z is equal to angle BCA, but angle BCA is equal to 38 degrees plus 20 degrees, that is 58 degrees. Hence, Z is equal to 58 degrees. In the diagram, ST, Q are points on the circle center O, PR is a tangent at T. If SQ is the diameter of the circle, calculate angle TQR. Let's go ahead and solve. From the diagram, angle OQP is an angle between the tangent and the radius. Let's recall the circle theorem of angle between tangent and the radius. It states that tangent to a circle is perpendicular to the radius at point of contact. That is, the angle between the tangent and the radius of a circle drawn through the point of contact is 90 degrees. Hence, angle OQP is equal to 90 degrees. Next we are going to calculate angle POQ. To do so we are going to consider triangle POQ. In triangle POQ, angle POQ is 180 degrees minus 34 degrees plus 90 degrees, which is 56 degrees. Reason. The sum of angles in a triangle is 180 degrees. Going further, notice that angle SOT is vertically opposite to angle POQ. Let's recall the theorem of vertically opposite angles. It states that vertically opposite angles are equal. From this figure, M is equal to N. Hence, angle SOT is equal to 56 degrees. Next, let's consider triangle OST. In triangle OST, line OS is equal to line OT. Reason. Both are radii of the circle. Since the two sides of the triangle are equal, it follows that triangle OST is isosceles. So, angle OST is equal to angle OTS. Reason. Base angles of an isosceles triangle are equal. Going further, let's find angle OST. This will enable us to find angle TQR easily. Since angle OST is a base angle of an isosceles triangle, it follows that angle OST is equal to 180 degrees minus 56 degrees, divided by 2, which is 62 degrees. Now we have known angle OST. Let's go ahead and find angle TQR. Notice that angle TQR is an angle between chord and tangent. Let's recall the circle theorem of the angle between the chord and the tangent. It states that the angle between a tangent to a circle and a chord through the point of contact is equal to the angle in the alternate segment. Since A, which is the angle between the tangent and the chord, is equal to B, which is the angle in the alternate segment, it follows that angle TQR is equal to angle QST. But angle QST is equal to 62 degrees. Hence, angle TQR is equal to 62 degrees. Thanks for watching. If you liked this video, make sure to subscribe for more.